people had moved.
You have 15 minutes total to address your challenge. Here is a resource that needs to be shared. There is your ocean, sea life. And the directions are here. If anybody needs any clarification, after, how about reading the task out loud, and then we can get started.
Without touching or smelling, create a hypothesis about the differences in the beakers of mystery acid collected from different areas of the planet.
And I didn't make this up. This is actually found on the surface of Venus. This obviously didn't actually come from Venus, but let's just say you're a scientist and you get this, and we'll just leave it from there in terms of implications for life on planets. And it really does make up 0.0004% of Venus's atmosphere. So it's kind of crazy to think about in terms of what scientists go through in the search for water and subsequent life. So have at it. And just one person needs to have the group hypothesis written down. So, got 10 minutes.
They're all the same.
Drop it in.
Uh-oh.
Right?
It's different settings. That's very
I'm looking from 4 different sites.
Oh my god.
So you can see how strong the atoms are in different places by seeing how they react to similar masses.
We have that like semi-strong.
Like a
so A, obviously.
I'm just.
Good job.
There, that's expensive. You know what you've done.
I wonder what it is that's coming on.
Drop the whole thing.
Oh, big piece. It says carbonate, so it's not like the same thing as what's in like
Calcium carbonate.
Do you think it's dissolving, or do you think it's just like reacting with it?
Okay, it's not doing it.
Yeah, it could be. So now let's just do the bigger piece on the next one.
Alright.
I don't know if this is the best technique, but
Yeah.
I can't think of anything else we could do.
We could try heating up. What happens to an acid when it heats up?
I'm starting notes.
Okay.
Well,
Yeah, more
oh my goodness, it's gonna fizz over. It's fizzing over.
Whoa, when are yours turned yellow?
It's not even going in anymore. Okay, let's try putting
Oh,
it
it's
on.
awful.
I told you it would come alive.
Isaac, hold your
I must make it a minion now.
Okay.
Isaac, hold out your phone.
So you guys, seriously, that will burn your fingers. So let me get a petri dish.
So that way if it starts to go over, we can.
Coral.
Yeah, it is.
I need
Coral.
I sacrificed it from my rock collection.
When you're ready for child, then you should be.
Ow. I feel bad for what's his
Okay,
name
so
is.
just to let you know, you have about 3 more minutes to come up with your hypothesis, because it looks like you guys have been able to
What do we have?
look at each of what the difference is in them are. I mean, they're all acid.
I think that A.
Sure.
Maybe A is the most acidic. That's what I said. B is
And then I get all
acidic, but not as acidic as A.
So you guys have your
C is
hypothesis.
a little bit acidic.
Where did it come from?
Second to least.
No, we didn't have it. I'm gonna try a little more.
Yeah.
I'm gonna try some more.
A is the most acidic from the way down.
Whoa.
Oh, A is very acidic.
Yeah.
I think it goes in order of acidic. Like it's just A, B, C,
Except for
D.
this one, D is also
Okay, so
That's at least most of these.
if you guys all
And then
have
C
your
is like-
hypotheses, we can put the stuff in the middle, and I'll clean it up afterwards and bring it back over here.
And B is the least. And the ones in between are just the same. I mean, A is the most, B is the second most. And so therefore it's reacting more with the A's.
Yeah. Water. No, it actually wasn't. I didn't lie. There is soap. It's all acid. They're all the same acid. I didn't lie.
They're all the same acid?
They're all the same acid.
Wait, are they like directions? Wait, are they like mixed? Is it all like the same water? Is it like same acid mixed with water? Or it's the same thing and everything does the same thing?
Okay, let's. Okay, so what's the third hypothesis? And we'll get back to that.
A is the most acidic. And B is
Acidic.
And it goes in order. A is the most.
Okay.
same as them.
So we're using the word acidic.
Yes.
Okay.
Because it reacted most violently for calcium.
Okay. So, so basically what we're talking about here is I heard the word strength, right? So we're looking at strength. So you guys, I think that it's the same acid and there's one, but it's the same acid, so one's stronger. So what's that mean? Okay. So basically what we're looking at is have you guys ever heard this word?
Concentration?
Right, so there's like mental concentration, right? Yeah, there's the game concentration. Have you ever heard of it in terms of chemistry?
Yeah.
Yes.
Okay, so that's what we're looking at. So when we talk about strength, we're kind of, we're looking at concentrations. Yeah, juice. I mean, it's all over the place, and it has nothing to do with solution. We were looking at the salt solution. When you're talking about concentrations in chemistry, it's how many particles per volume of mixture. And so when we're looking at particles, we're looking at atoms, molecules. In terms of the salt, we're talking about ions. Have you guys talked about ions? But basically, it's just different ways that atoms are bonded together. And then when a solvent is mixed with a solute, then you end up with a solution, and it's how much per volume. And so, in chemistry, there's a unit that's called a mole that we don't need to go into. But so if you come into something that says moles, really they're talking about a unit of concentration. It can be a percentage. And so these words, if you look familiar, I just erase them. You can actually kind of still see them too. Solvent, solute. And so in terms of solutions, it's how much solute is in a given solvent. And so it can be a percentage, it can be amount per amount. And so why are chemists great at solving problems? Because they have all the solutions.
Sounds like one of the things.
Oh, I have one really good one for the end. It's really painful. But okay, so how do you get the most into your solutions? So we were looking at dissolving before, and did you guys notice something that Heather, what was Heather doing, and what did you guys talk about in terms of how to get more salt into your solution? What are some ways? And I heard it back there. You guys were talking about
Heat it up.
Yeah, so you can heat it. What else can you do?
Mix it.
Yeah, totally. Did you see Heather, like she was mixing it and sort of stirring it as she was going? What else? How do you get more solute? How do you get more salt to stay in salt water?
More water.
No idea.
Adding more salt.
You can just add, but it might just sit at the bottom. So yeah, so we can heat it, we can stir it. This is something, so up there, so if I were to give you, if we had a chunk of salt and we were to put it in the salt water.
Alright.
Right, but if you smush it up, it's like the coral. I came in with a huge chunk of coral today, but you wouldn't have seen that good of a reaction unless, basically it would just react around it. And so
the coral's really good because it's got all the holes in it.
Totally, so it starts out with that, and then what did I do? I smushed it up. I mean, first off, so you could fit it into the test tubes, but also because of the surface area. And so going back to chemical reactions, you guys remember that? I know it was like 2 weeks ago, but you guys have probably been talking about it since then. So in terms of a chemical reaction, how would this apply as well? Hey, Rob. Come on in, grab a seat. In terms of a chemical reaction, how would surface area apply? Right, but why? On a molecular level.
Because there are more molecules that are being exposed to each other.
It just allows more people to come in contact.
Yeah, don't worry. Yeah, exactly. It's just all about contact. And so, yeah, so we've got surface area, stirring or mixing, temperature. And then a really special one is, for gases, is pressure. And why would pressure not apply to a liquid?
Just turn it into a rolling.
No, nothing would happen.
What was that?
Nothing would happen. It was just like a little
Right, because you can't compress, right? Yeah. Right. So, yeah. So that's one way to get the most out of your mixing or chemical reaction or solution. So, and this we were just talking about. Somebody was talking about heating up the solution to figure out, or heating up the acid to see if it would react more with the carbon. Yeah, I don't know how acids respond to heat, but
well, our hot springs are like really, really high temperatures. So.
Right, but I don't know if they're acidic.
They smell like sulfur.
They're sulfur. Some of them are, and some of them aren't sulfuric.
They smell so disgusting. Like the entire town smell awful.
Okay, so can we get the lights back on for a minute? Okay, so this is kind of like a sort of visual demo, and it's up there, but just sort of something to think about in terms of concentration. Sort of, I mean, back there we have these different acids that are different concentrations, and you figured that out by putting coral in it and seeing how it reacted and the chemical reaction that was going on there. But in terms of visual, you can have the same amount of drops. So 3, 4, 5, 6, 7, 8. And can I get a little stir, or sort of a little, what is that called when you just kind of, it's not really shaking it.
Swirl.
Yeah, swirl, gentle swirl. Do you guys remember how many I put in that one?
8.
8, okay. So, how many in this one?
5.
4? 1, 2, 3, 4. I'll do 4 because the math is a little, yeah, that's awesome. Okay. Julia, would you mind? Oh, sorry, Julia, and remind me. Oh, Camille. 2. And 1. Let's just do 1. Okay.
No water.
Is it water?
Yeah, really?
So pretty.
Okay.
Oh, my cousin has a whole music video.
So, I guess this is probably better.
So it's like pretty creepy because
I spilled it on myself.
Oh no. Good thing it's not acid. Did it get on your way? It'll be okay.
That's good.
Can I have that?
That's true.
Okay. You give it a little bit of a.
You made this marker.
So what we're looking at here is we're looking at different, I mean, you can look at this in a bunch of different ways. You could probably figure out percentages of how many drops, but you can also think of it in terms of, like, what are other ways you can think of it in terms of the relationship of drops of food coloring to water? What were you saying? I think it was good, but I couldn't hear it.
There's a higher percent.
Right, so there's a percentage.
There's the concentration.
Right, there's a concentration. There's a ratio for this. Like, I would, in order to make this easy math, I would probably say, like, units. So our units is I'm going to say, like, one drop of food coloring to, however many milliliters of water on there. And so, yeah, so that's it's sort of a visual way of figuring out. It's like, okay, so this would have been like our strongest, our most concentrated acid, and this would have been maybe our least concentrated acid. Okay, so we are going to, we're going to go outside real quick.